Welcome back, everyone. If you've been feeling like you're finally catching your breath after the recent releases of GPT-5.6 Sol and Claude Fable 5, I am so sorry, but you need to sit back down. Grab your coffee. Today is Saturday, July 18, 2026, and the landscape of artificial intelligence just underwent a massive seismic shift. For the last 2 years, the narrative in AI has been pretty static, right? Open source models were supposedly at least a year behind the closed proprietary giants like OpenAI and Anthropic, but in the last 48 hours, everything changed. In today's Explainer, we are breaking down why the open versus closed gap has officially shrunk to mere months and why a highly specific pricing trick is about to change how every single developer builds AI apps.
We are literally watching the foundational premise of the AI market shatter in real time. The idea that closed labs will forever dominate open weights is just gone. Over the last 48 hours, we haven't just seen your standard incremental updates. We've seen a complete reversal of the status quo, where closed models held this seemingly untouchable lead.
That's right, just 48 hours. In that tiny window, the release of 2 massive models completely shifted the landscape. A Chinese startup dropped a colossal 2.8 trillion parameter model that is actually beating Claude Fable on coding benchmarks, and on top of that, Elon Musk's xAI just unleashed Grok 4.5.
So let's get into Section 1, benchmarking the behemoths. Kimi K3 and Grok 4.5 enter the arena.
Let's start with the one that is absolutely haunting Silicon Valley right now. A startup called Moonshot AI just dropped Kimi K3. According to the Global AI Horizon report and APDog's architectural breakdown, this is the world's first open 3 trillion class flagship model. We are talking about a 2.8 trillion parameter behemoth armed with a 1 million token context window and native visual input. And look, it isn't just big for the sake of being big. It is actively dominating the leaderboards.
Just looking at the raw specs across these new titans compared to the closed frontier is wild. We have Kimi K3 stepping into the ring with those 2.8 trillion parameters. Right below it, Grok 4.5 brings a 1.5 trillion parameter foundation that's heavily optimized for speed. And they're standing right next to the proprietary standard bearer, GPT-5.6 Sol.
Now check out this number, 1679. Kimi K3 secured a massive 1679 ELO rating on the front-end code arena, which is a highly competitive matchmaking benchmark. It is functionally beating both Claude Fable 5 and OpenAI's GPT-5.6 Sol in this specific domain. On top of that, if you filter the text arena specifically for complex science queries, Kimi K3 is sitting comfortably at the absolute #1 spot right now. No contest.
But hey, we cannot ignore the other massive drop here. Elon Musk's xAI just shipped Grok 4.5. This is a 1.5 trillion parameter foundation model trained alongside Cursor on tens of thousands of NVIDIA GPUs. It is an absolute monster for agentic workflows, where the AI independently writes and tests code in continuous loops. It's easily outperforming previous heavyweights. On the SWE Marathon benchmark, Grok 4.5 hits 29.0%, overtaking Claude Opus 4.8 score of 26.0%, and it operates at an incredible 80 tokens per second of throughput. But as powerful as Grok 4.5 is, Kimi K3 is kind of stealing the spotlight right now because of what is happening under the hood.
Which brings us to Section 2. Under the hood, Sparse MoE and the 1 million token engine. Okay, to really understand why these models are such a big deal, we need to look at the underlying engine. Kimi 3 isn't activating all 2.8 trillion parameters at once. It uses a highly efficient mechanism called Stable Latent Mixture of Experts, or MoE for short. Basically, this sparse MoE architecture ensures that only a tiny, specialized fraction of the total parameters is activated for any given input, which massively reduces compute costs during inference.
Let's break down how that routing actually works in practice. Out of 896 specialized expert neural networks inside the model, it only activates exactly 16 of them for any given token. Think of it like walking into a massive university with 896 world-class professors. If you want to learn about Python debugging, you don't need to consult all of them, right? You only need to talk to exactly 16 of them for your specific coding problem. The remaining 880 professors, they stay completely dormant.
But it doesn't stop at parameter routing. When you stuff a 1 million token context window into an AI, which, by the way, is like stuffing a dozen massive textbooks into the AI's brain all at once, standard detention mechanisms choke. They just take up too much memory.
Well, Moonshot solved this with Kimi Delta Attention, a hybrid linear attention that decodes up to 6.3 times faster over these massive inputs. They also introduced attention residuals. This allows the model to selectively retrieve representations across the deep layers of the network, preventing it from forgetting context right in the middle of a massive document. So it doesn't just read a million tokens, it actually remembers them.
Let's move on to Section 3, the economics of AI, the cache hit pricing trick. As fascinating as the compute architecture is, the real revolution, the thing that is going to fundamentally change how every developer builds AI apps, comes down to economics. We are now dealing with a stark pricing reality. Check this out. While a standard request is $3 per million input tokens, a cache hit costs a mere 30 cents per million tokens. That is a massive 10x price drop just for reusing the same context.
So why does this matter so much? Because Moonshot's Mooncake inference stack delivers a greater than 90% cache hit rate on coding workloads. Think about those agentic coding loops we mentioned earlier. They constantly resend the exact same repository context, the same system prompts, the same file structures. Because of this caching trick, you are hitting that 10x cheaper rate on 90% of your requests. This completely changes the financial viability of running agentic workflows all day long.
When you look at the broader pricing market and combine Kimi K3's caching trick with Grok 4.5's aggressive flat pricing of $2 per million input tokens, well, suddenly high-volume internal engineering workflows are incredibly economical. Teams that were previously priced out of using frontier models for massive repositories, yeah, they can now run these tools continuously without breaking the bank.
That brings us to Section 4, closing the frontier gap. Let's talk about what this means for developers. Stepping back to look at the macro picture, the massive debate right now is whether these open-weight contenders have actually beaten the closed giants across the board. Well, the consensus among independent evaluators is summarized perfectly right here. It didn't take the frontier's crown, it shrank the lead to months. While broader evaluations like the Intelligence Index place K3 on par with Opus 4.8 and slightly behind the true frontier of Fable 5 and Sol, the true significance is simply this: an open model is now standing shoulder to shoulder with the frontier. It didn't have to win outright, it just had to prove the gap is closing. And get this, with the full weights dropping on July 27, 2026, developers are going to have to make a very serious choice. You'll have the option between paying for a proprietary API or spinning up your own frontier-class instances locally or on rented cloud hardware. Being able to self-host a 3 trillion class model, that completely changes the entire dynamic of data privacy and vendor lock-in. It's a real game changer.
So I'll leave you with this provocative thought to consider. As OpenAI systems continue this relentless pace, compressing a year-long capability gap into mere months, how will the proprietary labs justify their walled gardens tomorrow? The gap is closing way faster than anyone predicted, and the ultimate winners are going to be the developers building the next generation of applications. Thanks for joining me on this explainer, and I'll see you next time.